Hello, this is Mrs. Taylor, and I'm going to show you how to find dimensions of a rectangle if they give you polynomials as length and width and a given perimeter. In this problem, we have a rectangle. The length is represented by 6x plus 7. The width is represented by 3x plus 8. It says given the perimeter of the rectangle is 52 feet, find the value of x and the actual dimensions. First thing we need to understand is that perimeter is the sum of all the sides, and with a rectangle, opposite sides are the same length. So if the length here is 6x plus 7, the length here is 6x plus 7. Same thing with the 3x minus 8. The width is 3x minus 8. I can carry that over to the opposite side. If perimeter is adding all of those together, then what I need to do is collect all of these expressions and add them together. Now, if I wrote it out horizontally, so one long line, it looks a little intimidating. I would have plus signs in between each of these. And I would have to add up or combine my like terms. And when I look at that long line of terms, I get a little bit overwhelmed and I might not feel like conquering that problem. So what you may see instead is folks like to line it up vertically and combine your like terms that way. So that seems a little less intimidating than having that really long line of polynomials. And so if I add those together to represent perimeter, I would have my like terms, my x terms, 6 plus 3 plus 6 plus 3. That would be 9, 15, 18. So I'd have 18x, and then plus 7, negative 8, plus 7, negative 8. So 7 plus negative 8 plus 7 plus negative 8. So that would be negative 1, 6, negative 2. So minus 2. So if I combine all my like terms to represent the perimeter of the rectangle, the expression would be 18x minus 2. And if that represents perimeter, then that expression should equal the perimeter that they gave me, which was 52 feet. So this should equal 52. From this point, it's just a two-step equation. It was adding all these together that made this a longer process. Here, I can just add 2 to both sides. And remember, whatever I do to one side, I have to do the other to maintain that balance. And the negative 2 and positive 2 would add up to 0. They would eliminate. And then I'd have 18x on the left side. And then on the right side, 52 plus 2 is 54. And to finish solving for x, I would divide both sides by 18. Now, what you may notice is that once I had my equations set up, I just jumped right into solving. I didn't really explain why, but sometimes when you start working on a math problem, even if you aren't sure why you're doing the steps, sometimes it just happens without you thinking about it. And once I get 18 solved for, so 18 to, or I'm sorry, not 18, x. Once I get x solved for, so 18 divided by 18 is 1. 1 times x is just x. And then 54 divided by 18, let me grab my calculator, so 54 divided by 18 would be 3. So I just solved that because it was an equation that I knew how to solve. But if I go back and think about what that represents, if x equals 3, and each of these sides has an expression with x in it, I can now replace those x's with 3's. And so if I do that for length, 6x would become 6 times 3 plus 7. And then that can, be simplified. I can use the order of operations to evaluate. 6 times 3 is 18. 18 plus 7, well, that's 25. So without really knowing exactly why I solved the equation, once I get the equation solved, I now realize that my length is 25 feet. Units are feet for this problem. And then if I repeat that process for this width over here, so 3x becomes 3 times 3 minus 8, and evaluate that using the order of operations. 3 times 3 is 9. 9 minus 8 is 1. I now have my width as well. So when they ask me for dimensions, what they're asking for is the length and the width. And I now know that this rectangle is 25 by 1 feet. So that would be my dimensions for this problem, or this rectangle rather. So that's how you can find the dimensions of a rectangle when they give you perimeter and polynomial expressions.